Okay, so last time we looked at how to make a schematic or circuit using the given gate. Okay, so from today we will make some arithmetic circuits. First, we'll learn about the half adder. So we'll learn about the 1-bit half adder. Okay, so half adder means there are two inputs, X and Y. Then there are two outputs. One is just output, okay, like a sum. And the other one is carry value. Okay, so if we are writing the truth table, then it looks like this: X, Y, carry, sum. 0, 0, 0, 1, 1, 0, 1, 1. Okay, so 0 plus 0, that is sum is 0, carry is 0. Okay, X 0 plus 1, sum is 1, there is no carry. 1 plus 0, sum is 1, carry is 0. Okay, 1 plus 1, then there is a carry, and the sum part, the last bit part, is 0. Okay, so this is the half adder. Okay, so let's look at the carry part first. If we are looking at this carry part, which gate do we have to use? So 0 input, 2 input is 0, 0 case is 0, 0, 1 case 0, 1, 0 case 0, 1, and 1 case is 1. Which logic gate do we have to use? Okay, it should be AND. Okay, let's look at the sum. X, Y. If this X, Y value is equal, then it's 0. Input are different, then output is 1. So which logic do you have to use? Yeah, it is XOR. Okay, so we know that this part, then what do we have to do? We have to just draw. Okay, so using and XOR. Okay, there are two input. It will be the carry part. It will be the sum. Okay. Okay, so now what you have to do is you have to draw this one in the Logisim simulator. Okay, so let's look at the Logisim simulator. So can everyone open the Logisim? And also, can you turn on your camera? Okay, so open your Logisim and then draw and then XOR, which is in the gate directory. So there is XOR. And then, as you can see, we just need the two inputs. So let's change it, two inputs. And this one is also two inputs. And two inputs. And two outputs. let's give the label. This X. Second one input is Y. And first output is carry. Okay. And then you can change using this finger shape. So 1. 1 plus 0 is carry 0. Output is 1. 0 plus 1, 0, 1. If both are 1, then there is carry and output is 0. Okay. So can you draw? And then if we are finishing, please let me know in the chat window. And if you have any trouble, please let me know also. For instance, you cannot launch the simulator, or you don't know how to draw the gate. Okay, so I think everyone can do that, right? Okay, so this is a half header. Okay, so what we are trying to do is, let's try to load some library, existing library. So this is kind of a circuit, right? So using this circuits, you can make more complex circuits. Okay, so let's look at how to load existing library. In the LMS system, the portal site, you can download combinational CIRC and sequential .circ. So can you download it? So if you are going to the LMS system, you can download these two files. So if you did, please let me know. You already downloaded it, please let me know. So everyone can download it. Okay, then let's go to the simulator. Okay. So here, there is a project menu. There is a project menu. And if you're clicking the project menu, then there is load library, right? So in the load library, there is a Logisim library. So if we are clicking the Logisim library, then you can see that this dialog, right? So go to the project, load library, Logisim library, then you see that this kind of windows, and then go to the place. So go to the directory that where the combination are CIRC and sequential data CIRC. So go that place and then load it. Load library. Let me show you. That's okay. Here, there's a project. Okay, and there is a load library. Can you see? So there is a Logisim library. Okay. And then load the library. Try. Actually, I have a problem. I cannot find it. Where is it? Where is it? I can't find it. Okay. My machine has some problem. So everyone can load it. Can load the library. Okay, so my machine has some problem. So wait a minute. Actually, my machine cannot run it. So I think it has some problem. I don't know why, but close it. So, Doan, do you have an M1, Mac one, MacBook? It has some problem. Intel. So Intel MacBook doesn't have any problem, I think. Even this is not really working. Even after finishing, nothing's working. So let me figure it out. Okay, so I retry to open. Still, it's not going to work. Let me try it again. Sync. Okay, so it has some problem to load library in the Mac. So I will resolve that problem. So anyway, let's try to load library. Okay, so let me, I think there is arithmetic already here. So this one is 1 bit. So many bit you can change it. So anyway, it's not gonna be okay. So anyway. Okay, so just throw the half adder again. And using this half adder, let's try to make a full adder. Okay. X. So do the Y. Okay. Sum. I think you can change the name of this schematic. So this is half adder. Then it should be working. Why this is not working? Okay, so we'll add this schematic as a dual gate. Okay, so let's say this is. So I'm registering the 1-bit adder. Oops. Yeah, I registered that one. Here. You can draw this 1-bit adder here. So after you're making that 1-bit adder, what you can do is you can use that one as a library. And if you're going that place, this is X value, and this is Y value, carry, and sum. Okay, so after you are doing that, and then if you are pressing the right button, then there is a menu which is like a add a circuit library. So using that one, you can make us this new gate. And then if you're changing, then you can see that this is working. Okay, so after you're making some schematic, you can register that one as a another gate. Okay, so now we have this 1-bit adder. Now what we are doing is we will make a full adder. Okay, so let's design the full adder. One bit adder case, we just need a half adder, but if we are trying to support a multi-bit case, what we have to make is input should be 3-bit, X and Y, and another input is required to support the carry in from the previous location. So for instance, if we're adding 0, 1, 1, 0 plus 1, 0, 1, 0. In this case, this is 0, and 1 plus 1 is, let's say this is 1, is 0, and there's carry. Okay, so in this case, we have to add the 3 input value, carry, and X, and Y. So to make this adder, we have to support 3-bit input, and then the output is, there are 2, carry out and sum value. Okay, so this one is called full adder. So full adder is supporting the carry input. It's 1, and this is 0, and 1. Okay, so let's look at the full adder case, carry out sum. Okay, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1. So here in this case, carry out. This is 0, 0, 0. And if there are more than 2 bits, then it's 1, it's 0. If there is more than 2 bits, it's 1, 1, and this is 1. Some case is 0, and there is other numbers 1, then it's 1, 1, 0. Here this is 1, in this case 0, this case 0. 1 plus 1 plus 1 is 1. Right? So this is output. So using half adder, we can make this full adder, or we can make a full adder directly using AND or XOR gate. Okay. So first, let's look at how to make this full adder using this half adder. So first, using half adder, we can add 2 inputs, X and Y, right? Then it is generating the output. Carry and sum. Okay. We have to use another half adder. So if the sum is 1, then it should be added another one. So it's a carry in, then it is generating the carry and sum. Okay. The carry case, carry is generated when one of them is generating the carry. Okay. So that is carry out, and this is really sum. Right? So everything is 0, then C out is 0 and sum is 0. If this is 1, y equals 0, and c equals 0, in this case, the first half adder is generating the carry is 0, sum is 1, right? So 1 plus 0 is carry is 0, sum is 1, 0 or 0 is 0. So 1 plus 0 case, carry out is 0, sum is 1. If x is 1, y equal 1, there's no carry in this case. First half adder is generating the carry, and some value is 0. 0 plus 0 is 0, and 0, 1 or 0 is 1. So 1 plus 0 is carry out is 1, and some part is 0. So you can see that in this case, this is correct. Let's look at another case. For instance, this is 1, this is 0, and this is 1. Okay, so in this case, the first half adder, the carry value will be 0 because 1 plus 0 is carry 0, some part is 1. 1 plus 1 is sum is 1, sum is 0, carry part is 1. So 0 over 1 is 1. Okay, so you can see that 1, 0, 1 case, 1, 0. That is up. Okay. And if everything is 1, then one plus 1 is carries 1, some part is 0. Okay, so this is 1. 0 plus 1 is carry part is 0, some part is 1. 1 or 0 is 1. So carry is 1, sum is 1. Okay, so 1, 1, 1 case, so 1. Right? Okay, so then can you draw this one in Logisim Simulator? Okay, there is a half adder. This part. We'll do another half adder. Okay, so this is half adder. And there are input, and this is carrying. And this is some part. Okay. And then I'm using dust X4. This is carry. Then after this, so this will be X, this will be Y, this is carry in, this will be carry out, this is some part. Then if you are giving the 1, 1, 1. Okay. So you can see that this is working. Okay. So if you're completing, please let me know. Let's change the name to the full letter. Okay. So this is full letter. So this is so using this full header, what we can do is we can make a multi-bit header also. So let's try add another circuit. Okay, so add a circuit. So if you're clicking the right button, you can do the add circuit. Add circuit. So here, let's try the 4-bit header. So there's a 4-bit header. So what you can do is, so here this was a schematic, right? So we draw the half header and we also draw the full header. Okay. So this is full header. If you're clicking the half header, you can see that the schematic. Okay, so let's go to the 4-bit header. Okay. After drawing and add another circuit, which is a full header, and drawing the full header, And then using this full header, we will make a forbit header. So in the forbit header, what we are doing is we are just copying full header. And then we are giving inputs, which is X and Y. And the first should be carry case, it should be 0. Okay. And this will be sum, the first output. Let's change the inverse. And then the first output is going to the so this is X0 value, and this one is Y0. Second bit is also, this is this is X1, this one is Y1. Third bit. And last bit. And previous carry is going to the next bit. And last one. Yes, carry out. So this is first out, second one, third one, last one. This is carry. Okay. And this is 2. Okay, so this is forbit with letter. Forbit. Especially this is called what you can see, changing 1, 1, and generating the carry, and the per bit will be 1. This here, here. So you can see that this is correctly working. Okay, so if we are completing the making the full header, then trying to make this forbit ripple carry header, if you are not completing the full header, please draw the full header first. In order to make this full header, you have to make a half header first. Okay. Okay, so draw the figure, draw the circuit. Now, please. So everyone is completing the full header, or do you have any problem for the full header? Or any problem? So if you are completing the full header, please let me know. And also if you are completing the 4-bit ripple carry header, also please let me know that. So after you are making this ripple carry header, what you can do is you can utilize this ripple carry header using a gate. You need you can change the circle layer also. Change that anyway. Okay, so drawing this ripple carry header is homework. Okay, so you have to complete this ripple carry header, and then next time we'll continue about some another combinational logic like a decoder and multiplexer. Okay, I think some machine has some problem to load library. So Logician library doesn't show any correct dialogue. But anyway, using this existing built-in library, we can make a processor. So we will use the existing library in the next class. Okay. Any question? Okay, then see you next week. Okay, Kim Dong-hyun is saying that after installing the Java 6, without extracting the package, then it's working. Okay, but anyway, well, we don't need actually the CIRC, combinational CIRC and sequential CIRC because everything is already there. Okay, so we'll use this library. Okay, see you on next week. Bye.